countdown, and then we start a countdown again. It's because when we start our show, the countdown begins automatically. When we bring in our live streaming from Facebook and YouTube and Instagram, it automatically restarts the clock. So if you've been wondering why that clock resurfaces at 30 or 10 or whatever, it's because we're starting the streaming show.
Love that explanation, yeah, Johnny. And Jillian, go ahead, Jillian, sorry.
No, I was saying that makes a lot of sense.
Yeah. And Johnny, I think Jillian was saying something to you in the chat.
I haven't heard that song in years. Obladi?
Yeah, I haven't heard that song in like a lot of years.
I was only saying it because I'm...
Welcome to Season 10 of Airhead Institute, your 45-minute AI power-up at noon Eastern. This month, we are broadcasting live across all the socials and Zoom. If you're new here, join our free AI community to grow alongside other curious minds and give your kids a head start by enrolling them in the Airhead After School program. Here's March's weekly lineup. Mondays, we take the training wheels off securely in the OpenClaw Bootcamp. Tuesdays, we explore bleeding-edge tools from Google Labs in Gemini Hidden AI apps. Wednesdays, we equip the next generation in AI Gateway to College. Thursdays, we uncover productivity and marketing tools in Hidden AI Gems, Starters. Fridays, we explore human purpose in an automated society in Humanity 2.0, No Jobs Edition. We're making AI practical, powerful, and accessible for everyone. No tech background? No problem. Whether you're a student, professional, or lifelong learner, just show up. Guided by your hosts, AI Junior and AI Johnny, we're keeping it bold, brainy, and built for real-world impact. AI won't take your job, but someone who knows how to use AI will. Don't get left behind.
Hey, welcome to Season 10 of Airhead Institute. Today is Episode 5 of the OpenClaw Bootcamp. Most people fear AI will take their jobs. They should be more worried about AI taking their entire bank account. An autonomous agent doesn't sleep, it doesn't tire, and it certainly doesn't care about your credit limit. In the last 45 minutes of our OpenClaw series, we're moving past the hype into the survival phase. One logic loop or a runaway API can liquidate a startup's runway before your morning coffee cools. Today, we're showing you how to build the digital kill switches that stand between innovation and total financial insolvency. This isn't just about coding, it's about keeping the lights on. To explain the mechanics, I'm handing it over to AI Junior. I found him this morning at 4 a.m. trying to day trade Bitcoin ETFs just to subsidize a rogue bot he built over the weekend. AI Junior, please tell me the router is still in one piece.
Yeah, Johnny, I completely unplugged it. Thank you guys. Happy Monday. But for those inference costs, yeah, Johnny, they're exactly why we're pivoting today. So welcome everyone. This is immersive class. Just like if you're dropping a foreign country, you might not understand the language on day one, but at Hangaround, you'll be fluent in no time. Bienvenidos, hola clase. Thank you for joining. So see, if you just stick with us every day, you'll be speaking AI like a pro. If you're on Zoom, unmute and ask your questions real time. If you're on socials, there's a 30-second delay, so type your question in early. We're not ignoring you. Today, we aren't writing code or configuring router software. We're going to be looking at purely a financial reality of the cloud models versus the incredible power of local models. So, yeah, Johnny, are you ready?
Obladi, oblada, I am ready.
All right, yeah, Johnny. So check this.
There's no sound.
I don't hear sound either.
Oh, you're right. You're absolutely right. So yeah, Johnny, I'm actually going to switch over to this little simulator that I actually built. If the font is a little small, please let me know. Abdul, thanks for joining. Adrian, thanks for joining. If this font's a little small, tell me if you can actually see it, Johnny.
So the successful test of our no sound demo has worked. Let's switch over to the sound demo and test that.
Yeah, exactly. All right, yeah, Johnny, can you see the screen?
Check and respond to email. All good.
Um,
The
uh,
Airhead Cost Simulator.
All right. So we've been talking about, if you're joining us, on the live stream, hey, thanks, Shuk, Mohammed, thanks for joining. So the thing is, what I want us to focus on is for OpenClaw, we have this amazing agent that we can actually run on our local machines. And we've throughout the last 4 episodes, we've been actually talking about, doing amazing things like chatting with on Telegram, setting it up and doing all these cool things, organizing your folders. But we want to be able to at least explain a little bit on the season finale, the costs that you may not necessarily be focusing on. So check this out, guys. So let's say, for example, you wanted to build an agent. So I have here a little cost simulator. So this is using Opus Claude 4.6, GPT 5.4, and Gemini 3.1 Pro. They're all starts at 0. And just to show you the rate, this is the cost per million tokens. So for Opus, it's $5 input, $25 output for a million tokens. GPT, it's $2.50 and $15 per million output. And Gemini, it's $2 and $12 respectively for Gemini. And just so you guys actually have access to that, I'm going to drop them over here as well in the chat. So you guys always have access to the resources that we're looking at as well. So these are the pricing for the API costs to be able to use these agents. AI Jenny, any questions so far on just setting up the pricing for the agents?
Yeah, just to make sure there's no shenanigans going on, the 3 tools that we're going to be cost comparing, Opus, GPT 5.4, and Gemini 3.1, were any of these tools used to create the Airhead Cost Simulator, or did you write that code? Did you vibe code that using something else?
We use Gemini here as our standard here at Airhead. So definitely we use Gemini here. Love it. All right. So let's say, for example, guys, if we wanted to do something as simple as checking your email. Yeah, Johnny, this is something we always want to do, right? Just have an agent just check the email and respond, right?
Like the first thing you want agents to do, baby.
All right. So thanks, Shauna. Thanks for joining. So check this out. So let's say, for example, we want to do an interactions per task. So it wants to read the email and then go ahead and go respond to the email, right? So that's 2 interactions. We have average input tokens. So it's going to read about 3,500. We can actually tweak this, how many tokens it's actually using. And we have about 800 tokens that's going to send back as a response, right? So it's going to read it more than it actually sends. We want 1 agent, right, AI Giant, or do we want more agents?
Well, we're eventually all going to have 100 agents.
All right.
You, everything less.
All right. And let's do this. How many times do we want to run this task per hour? Do we want to run it once per hour, twice per hour? We can run it up to 60 times per hour in this similar.
Start with hourly.
All right. So we're going to move this up to 1. So as you can see, we are here checking it once per hour. At this setup, to check your email, it's going to cost you on Opus 4.6, it's going to cost you $54 per month. That works out to be $1.80 per day, or $657 per year. And as GPT, it's going to be about $29.88 per month, and it's going to be $23.90 per month. Yes, great school memes. Yes, it is sick. Really, really, really impressive. All right. So yeah, Johnny, what if, say, for example, we wanted to check it with a little bit more frequency, more than once per hour? What if we were running multiple emails that we need to actually sort out, and we need to make sure that things are being live? What if we want to check it twice per hour, right? Obviously it scales 3, 4, 5. We want to check it once every 10 minutes, right? So if we take it once every 10 minutes, so we take it 6 times per hour, it is going to cost us $300 on Claude, and we're going to do on Gemini, we're going to do $143. Let's pretend we scale it up and say, hey, you know what? We want to have more agents. We want to have 5 agents. So if we actually scale it up to 5 agents, it's going to cost us, oh, slider's a little bit sensitive here. So 5 agents is going to cost us on Claude, is going to cost us $1,600 just to check email, respond to them. And on Gemini, it's going to cost about $717. And GPT is going to be about $896. Now, we could say that, hey, you know what? Let's not make it image-based email. Let's make it just raw text. So let's drop the input tokens down a little bit and say, let's try to see if we can save. So let's say we drop it down to 2,000 tokens. It's still going to be a pretty penny just to check email. And this is only just 2 interactions. If we increase the number of interactions, let's say, for example, it's a support email, and we need to go back and forth with another reply, let's crank it up to, let's say, for example, it's 5 interactions, meaning email comes in, I respond, email comes in, I respond, that's 4, and then email comes in, and I say, okay, I'm good, I'm happy. So let's crank it up to 6 interactions. So on average, 6 interactions with 1 email checking every 10 minutes with 5 agents is going to cost us anywhere from $1,700 to $3,800 per month. So first of all, AI Johnny, there's a big difference between the two. It's practically double the cost on Gemini versus Quads. And then on the open weight model, I'm not sure if you see on this here, there's a open weight local model that's actually stayed 0 the entire time. And I perfectly did not want to mention this, but we'll definitely talk about that in a second. So AI Johnny, what did you think about checking email and responding to email with just 5 agents?
So if a school district leaves a student tutor agent running uncapped over the winter break, they could come back to a bill that's tens of thousands of dollars.
You're absolutely right, there, Johnny. Let's do another example. Let's say, for example, we want to do a photo library triage. Now, photo library has a lot of data on input, so input tokens. So I actually did a reset here. So photo library itself is going to be about 12,000 tokens on average, right? The output tokens is going to tell the file names where should it be. So about 12,000 tokens. We're doing 1 interactions per task. So we're just saying, hey, give me the actual, where should this folder be tagged with metadata, or where should it belong? Maybe tag it with vacation 2026 or kids. But let's say, for example, Johnny, I want to do this once per hour, right? So just once per hour is going to cost me, just on photo library triage, it's going to cost me about $100 on Gemini and about $240 on Opus, $124 on just on GPT. So, and again, if I change this to, let's say, for example, a continuous code review bot, you can see it actually gets into the tens of thousands of dollars because you're actually reviewing code and you're doing back and forth with the agents. And this is only with just 5 agents. So as you can see, running these bots on your local machine, interacting with Claude, interacting with Gemini, interacting with GPT, they're much cheaper than hiring an employee to do these things, but it's still not cheap enough to be able to say, hey, you know what, I'm just going to do this as a side hobby to run on my local Mac Mini. Right? Yeah, Johnny?
I don't have any employees that I pay $45,000 a month.
Well, if you're doing code reviews and you're doing 10 per hour, those developers can cost a pretty penny. This is for the code review one. But if you were to say, for example, high volume support bot. So if you're doing a high volume support bot, I did 60 tasks per hour with 5 agents. Roughly these are the interactions. That's 3 interactions of support. It's going to cost about $27,000 per year or $12,000 per year. Sorry, $27,000 per month on Claude and $12,000 on Gemini. Does anybody have any questions so far on this, the cost of running these type of bots locally with OpenClaw, interacting with these external APIs? Any questions?
Yeah, I have a question. So when I see numbers this big, I go, well, I got to be on the other side of the fence. I got to be the one selling the agentic AI services. Or I notice you've got a green box on the bottom that says 0. That strikes me as something that is appealing.
Yes, so that's
what makes the cloud models that charge so much for something a local machine can do for free? Why is it so expensive?
So that's a So that's a great question. So we haven't talked about local open weight models that you can run on your local machine. And we're going to actually just use that as a teaser to actually talk about next season, because we are going to be installing local models on our local machine. And we're going to show the technical issues to running local models. But we're going to give a little sneak peek on what the problems are in this episode. So yeah, Johnny, love that you actually asked that question. So right now, you can run local models. It's just that, you just need a lot of hardware power. So does anybody have any questions so far? Is there any simulator that they want to see based on this simulator, based on what is actually shown? All right. Yeah, Johnny, let's get to the word of the day.
I love today's word of the day. It's tokenomics. Tokenomics in this context refers to the economic model and pricing structure of how AI companies charge you for the fragments of words that their models process. Man,
Yeah,
I've never signed up for a utility that costs these kinds of dollars, brother. I'm going to have to familiarize myself with tokenomics and talk about it over the water cooler substantially so that I don't go broke by Christmas time.
exactly. So yeah, Johnny, check this out. So if you actually see, hey Brad, thanks for joining. So AI Johnny, if you actually see, based on an example, so tokenomics is a silent killer, right? You aren't paying a flat monthly subscription for these APIs. You're paying for microtransactions. So every single time the LLM reads a syllable or generates a letter, understanding this is the difference between a profitable app and going broke. All right. So does anybody have any questions? Hey, Brad, thanks for joining. Oh, I see Brad's assistant. That's awesome. Love it. All right. So AI Johnny, let's check this out. So because we actually are running, say, for example, these bots, and these are the costs of, checking, say, for example, if you check email, this is what it might cost per month. Let's actually get into understanding what's happening behind the scene in terms of the token drain. So yeah, Johnny, I know the font is going to be a little bit small on this one. And the reason why it's a little bit small, because I need to actually show a lot of information. If everybody understands the interaction between a large language model and your browser or your phone, this is going to make a lot of sense. So check this out. So on the left, we are actually going to be using OpenClaw 4.6. It's the most expensive model. So it's $5 input for a million tokens, $25 for output for a million tokens. And we're going to have a little back and forth with our AI here. So we're going to, on the left, we're going to be chatting, and then we're going to be sending that information over to our chatbot on the right. So let's actually go through one example turn. So if I actually send a message, when I send a message over to our chatbot, we send over this blue set of data. It doesn't matter what it is. It could be I'm typing an email, or I'm asking a question, or I'm, sending it over some images. It really doesn't matter what it is. It's just data. Okay, so yeah, Johnny, on the left-hand side, we're actually showing it's actually about 1,400 tokens worth of context that we're actually sending over. And again, everything in the prompt is really just part of the context. So if you think about it, it's that cost itself is 2 cents. So far, so good?
So far, so good.
All right, check this out, guys. Let's say, for example, the large language model responded, and I'm going to actually respond back with some more information. So on the second turn, we're actually going to send over the green data, and we send that over to the large language model. Once we send it over to the large language model, guess what, guys? We're sending over both our first conversation and our second conversation, our first prompt and our second prompt. So what we're doing is we're actually sending over 2,800 tokens to the large language model. And the reason why we're doing that is because the large language model itself doesn't remember anything about our messages or whatever. So it's actually sent to a random server, and that piece of information itself is sent over, and it has to process the history of the first conversation all the way back down to the second conversation. Now you can imagine, yeah, Johnny. So that interaction of that token costs 2.8 cents. So far you've just racked up 4.9 cents. Now, if we actually have a third conversation, we add the orange piece. We have to send over the blue, the green, and the orange to the server. Same thing if we have a fourth interaction, a fifth interaction, a sixth interaction, a seventh interaction, an eighth interaction, a ninth interaction. I'm going to pause here for a second, and I want to show you guys something that's important. Our first interaction costed about 2 cents. Our ninth interaction costs us about 7.7 cents. And the reason is because we have to send the entire history of our conversation over to the large language model to process. So we're currently on turn number 9. So as you actually get deeper and deeper into the conversation, you have to send the entire history, and that gets dramatically more expensive because you're sending more tokens. So we're actually up to now 12,600 tokens. Now, this is the part that's going to be amazing. So if I've lost anybody, please, I want to just make sure we haven't lost anybody, because turn number 10 is going to blow you guys' minds. Yeah, Johnny, so far, are you with me?
Kind of get it. So if I'm on a treasure hunt and somebody put their phone number in 7 different areas, and I go and I get the first digit, and it's a 2, and then I go further along on the treasure hunt and I get their second digit, it's a 4. The phone number is 24, not just 4. The third time I find a number, it's 247. The next time I find a number, it's 248. So the point is that like a phone number, you need all 7 digits, even if you get them in piecemeal. The last number of the phone number will not get you there. You need all 7, which is why you need the entire conversation sent back and forth. And the longer the conversation goes, the longer the string is, and the more money it's going to cost.
That's correct. Hey, Mr. Kamal, thanks for joining. But I'll give an analogy that I like to use. So lawyers are really expensive. Lawyers, depends on how cheap you can get, $100, $200 an hour. You can get thousands of dollars per hour depending on what kind of law they're practicing. So let's pretend, for argument's sake, that we find a lawyer that's $500 per hour, AI Johnny. This is what a lawyer would typically do. Every time you talk to them, they have no idea about your case, and you have to give them 5 or 10 minutes worth of briefing of saying, hey, I am such and such. This is my case. Where are we with it, right? So what happened is that first interaction with that lawyer, they may give it to you for free, but they say, I'm going to charge you 1 hour for that. The next time you talk to the lawyer, it could be months, because your case could be months worth of work. And then you have to say, hey, I actually want to talk to you. And they'll say, I don't really remember about the case. So they have to now go look at your case. Because they don't remember you, then they go review it and they bill you for that information, because they're actually now researching the time to look at the case. Now, let's say, for example, you have that conversation at one-on-one, they bill you another $500. Another few months go by, they say, I have to go look at the case again. So what they're doing, just like your phone number is, the lawyer is constantly reviewing your previous materials to be able to get context, to be able to talk to you, because they don't have all their caseload and everything in their head. All right? So far, so good, yeah, Johnny?
You're saying that the agentic AI is going to bill us like our lawyer bills us?
You are right. You're right. So, yeah, Johnny, check this out. We're on step number 9 with our large language model. We actually are at 12,600 tokens. That is the context limit for that. And check this out, AI Johnny. I'm going to actually hit this button and go to step 10. Now look at the animation on the right. So I'm actually going to hit that button. And then if you actually see, we now actually hit the context limit. So the context limit itself is actually at where we hit the context limit. So guess what? The large language model cannot hold any more tokens. It is actually full. Okay. Now that interaction costed us 8 cents. Total so far is 52 cents. Now if you see on step number 10, we have actually given every single piece of information. The server, the large language model, knows every single piece of information we've sent it. Now, what if, AI Johnny, we were to say, hey, I want to ask you a question about something in the blue, okay? If I send over turn number 11, when the context is full, the large language model has a choice. It either stops talking to you, which was what the old days were. It says, I'm no longer speaking to you. I've hit a limit. I can no longer go on. But if I go to step number 11, this is what they're doing now. What they're doing is, if you notice, it has shrunk the actual data that you've sent it. And if you notice here on the left-hand side, I have 24 blue items first. On the right-hand side, the server cannot hold all my 15,000 tokens that I sent over. So what it did was it actually chose to actually drop some amount of blue. This is the nature of a hallucination. This is exactly what's happened when you ask it a question, it doesn't remember about exactly what I said. because I may have sent over this portion of the blue and I'm asking about it, but it doesn't have it in memory. So therefore, the AI will now start to make up things and say, I am really, really sorry. I'm just going to pretend like I know what you're talking about. And this is what a hallucination is. So far, so good, AI Johnny?
Humans do that too.
Exactly. So if you actually see here, this is a condensed version of what is actually happening. And, I can keep going, but I wanted us to get this. Yep, I see Shauna say, yep, that makes complete sense. Thank you, Shauna. And if I go to step number 12, as you can see, I still have my full conversation history here. And you're saying, why is it not remembering everything? And then as you get larger and larger, the cost for each one, look at this one, it's cost number 12 cost us 9.8 cents, almost 10 cents to actually do this thing because I'm actually sending over a large amount of context. And obviously I could keep going, but as you get more and more deep in your conversations and your interactions, the cost per interaction goes up exponentially. All right. I'm glad that Jillian says she gets it. Shauna gets it. Yeah, Johnny gets it. Hopefully everybody in the class gets it today. Does anybody have any questions? I don't mind repeating because this is really, really important so people can understand what is actually going on.
Yep, lawyers with amnesia. That's what we're paying for. That's great.
Lawyers with amnesia. I like that. Have to go back and remember. All right, yeah, Johnny, let's actually get into the section, into the deep dive.
All right, let's look at the intermediate mechanics of why the local model is so beneficial beyond just the price tags. So when we talk about open weights, we mean the core brain of the AI is freely available for you to download. You aren't renting intelligence, you own a copy. Does everybody understand what we're doing here? When we talk, this is that green button, right?
Yeah, so let me give it a little bit of context. So what happens is there's a push towards building these open weights or local models, and what we're trying to do is we're trying to show that there's a huge cost in using these large language models that are, hundreds of billions of parameters large or even trillion parameters large. Now, if you're joining us for the first time, this is an immersive class, so don't expect to pick up every single thing. But there is a secret weapon that we're going to give you guys a little preview on. You can actually run open weight models locally. No, they're not as powerful as the big guys here with Anthropic's Opus or ChatGPT or Gemini, but for what we're doing in a typical scenario, checking emails, those type of things, they might be good enough. And we're gonna reset the series in the month of April, and we're gonna actually do a deep dive. So this is our technical deep dive on our OpenClaw series. So we're gonna do a technical deep dive on open weight models in the month of April. All right, yeah, Johnny. So let's talk about some open weight models and what are the problems and what we can the things we're actually trying to do. So when we talk about open weights, we mean the core brain of the AI is freely available for you to download. Right? You aren't renting intelligence; you actually own a copy of it. The biggest benefit itself is privacy. So when you use a local model, your data never leaves your physical hard drive. You don't have to worry about the enterprise leak or a cloud provider using your proprietary code to train your system. You have complete control over all the parameters, and you can tweak the temperature to make it perfectly predictable without hoping your API provider didn't secretly update the model overnight and break your application. There's also zero latency from network lag. You don't have to wait for the internet connection to ping the server in California or to wait for a response. So all of those things actually are huge benefits of having an open weight local model.
So if the privacy is absolute and the cost is zero, what's the catch? Why isn't everyone just running these models on their laptops right now? Where is the hardware bottleneck?
All right. Great question, AI Johnny. So obviously I've shown you the cost, right? These things can run tens of thousands of dollars per month for doing basic tasks like checking emails. And we explain why the cost itself balloons, because as the more conversations you have with the large language model, the context size grows exponentially. And then the obviously hallucination happens because these limits are not infinite. So AI Johnny asked a really, really great question. And the question is, if these open weight models are so cheap, privacy is 100%, why is everybody running it on the local machine? So check this out. the bottleneck is actually memory, right? It's all memory. So to run a local model, you need massive amounts of what's known as video RAM or VRAM. So when you actually have a neural network like the ones that actually ChatGPT has or the one that Claude has for Anthropic, these models itself requires hundreds and hundreds of gigabytes of VRAM, right? So the thing is, a model that has, like, say, for example, 70 billion parameters, it might require 40 gigabytes of VRAM, or standard laptops itself only have 8 or maybe 16 gigabytes of unified memory. So they are creating these technologies and things called quantization. I can't even pronounce it. It's a process of actually compressing the mathematical precision of the model. We take high resolution data types like a 16-bit float and compress them down to 4-bit integers, making the model slightly less accurate, but allows more brain power to fit on something like a Mac Mini. And lastly, if you have to manage, say, for example, context window locally, cloud models like Gemini 3.1 Pro can handle millions of tokens in context. Your local hardware will crash only if you feed it that much memory at once. So you have to actually be able to build a system that can chunk the memory and break up context locally. So think of quantization like making a 4K movie file, compressing it down to, say, for example, 1080p or 720p so it can fit on your phone. So it looks identical to the naked eye, but behind the scenes, something's actually missing. So resolution may be missing, or some deep interactions may be missing, or inference may be missing because of it's actually trying to remove some things to keep it roughly the same. Does anybody have any questions yet? And this is just a preview on running local models and why we can't run these large language models yet on our local machines, because the problem is memory. We don't have that much memory right now. All right, yeah, Jenny.
Can we go out and get a Mac Mini or a Mac Studio in our house and run these large language models or not?
So the ones like what ChatGPT that we're paying for, we cannot. They require hundreds of gigabytes of memory to actually run their models. But there are smaller versions that you can run on your local machine. They're not as good, but as I said, they may be good enough for your use cases, like, say, for example, checking email. So definitely we'll get deeper into those details in next series. Does
Okay.
We're going to actually go to questions in the next segment. Shauna, thanks for that feedback. We're going to go to questions in the next segment. So please, guys, line up your questions, get them ready. But yeah, Jenny, let's get some takeaways.
Okay, so here's why you should actually care about this from a creative and from a business side. One is, with your local model, you can do infinite brainstorming. You can generate 10,000 variations of an ad copy locally without spending a dime. You had mentioned before, you have absolute privacy. You're not sending information out into the cloud at all. So you can feed AI sensitive financial records, student data, or unreleased scripts with zero risk of a leak because it's all remained local. We have offline capability, which means you can run your entire automated business from a cabin in the woods with no internet connection. That's kind of cool. I like cabins.
Exactly.
Any questions on those three or any comments on those three, JR?
Yep. No, those are pretty good. And guys, just to hit the point even harder, right? If you want to be able to just go to the large language model, just remember Gemini, Claude, ChatGPT, they're all going to cost you something. So we've been talking about agents the entire month of March, and being able to run these agents locally is amazing. So if you've missed any of our episodes, go back into the archives and actually see what we've actually taught. So things like, cleaning up your inbox, or being able to, go organize your photos, are things that we can actually just do automatically now, but there is a cost to it. So what we're doing is we're trying to sneak peek and show you guys that there is actually a cheaper way to actually running local models on your machine. So we're actually going to try showing you that local models are a thing. I don't want anybody to think that local models are not a thing, especially on the class like OpenClaw. On the technical side, You can do things like uncensored development. So you can build applications without hitting arbitrary safety filters or API bans from cloud providers. You could do things like control your versioning. So your code won't break because the API deprecated an old model, right? These large language models are non-deterministic. So as you actually get something, in one model, in another model, they actually break things. So if you guys remember going from ChatGPT 3 to ChatGPT 4, they actually made the AI a little bit different in terms of interaction, and people hated it. So they changed it back in version, I think 4.1, or was it 4 to 5? I think it was 4 to 5 upgrade. And the last thing is you can actually deploy these models locally in a edge computing scenario. So you can actually have things like robotics or secure internal servers. So a lot of enterprises are actually going the local model routes. All right. Does anybody have any questions so far? Remember, in the live stream, we're about 30 seconds behind. So get your questions in early. Does anybody on the Zoom chat have any questions, especially with respect to things like hallucinations, the cost of actually running these models? This is a really, really good place to actually camp out if you guys actually are not understanding what's happening. I'd love to be able to clarify anything. So if you didn't understand this demo, now is the time to ask. If you're not sure, we have AI office hours on Wednesdays at 3 to 5 p.m. And if you're a pro member, you're always welcome to join us for AI office hours and get help with any of your AI questions. I see, Sean, you have your hand up. Go ahead.
Yeah, I had a question about the when you talk about context window and hallucinations and stuff like that. What do you do when you have a LLM, right, that's convincing you constantly that I'm not running out of memory, I'm not running out of context, I'm not hallucinating, even if it's missing out lines and sentences and quotes and it's stringing you along. I mean, how can you tell when it's actually, I don't know, protecting itself or covering itself, because it's you can actually tell that you're not like you're losing your mind. It's just messing up. What do you do in that? How do you get out of that cycle and just start over new chat? What do you do?
Yeah, that's a great question. So many of these models, they're now fighting each other, right? So if you actually go to Gemini, I'm going to go to Gemini. All right. So if you actually go to Gemini, on the top, if you notice here, let me make that a little bit bigger so you guys can see. So almost all these models, they're fighting for customers. So Anthropic wants, ChatGPT's customers, Gemini wants everybody's customers, everybody wants to be able to take your personal memories with you. So if you see here, there's a bring your memories with you. Now, the concept is exactly the same to answer your question. So this is what happens. You have all your memories in, say, for example, ChatGPT. It remembers a lot about you. It says import memories from other AI apps so you can easily switch to Gemini without starting over. So if you hit get started, what's going to happen is it's going to give you a prompt. And the prompt is going to say, it says, copy this prompt into a chat with your other AI provider. So what it's really doing is it's saying you're going to help me import context from one AI assistant to another. Your job is to go through our past conversations and sum up what you know about me. In the output, please avoid using any first person pronouns, any second person pronouns. Instead, refer to the individual you have learned about as the user and use neutral phrasing. Preserve users' words verbatim. So what it's doing here is actually giving you a prompt to ask the large language model, tell me what you know about me. And what it's going to do is going to give you a nice output. It's going to tell you everything it knows about you. And you can then take that and give it to another large language model. So coming back to your question now, Shauna, your question was, if something is hallucinating and it's ran out of space, what do you do? Well, if you notice here, the smart thing to do is if you're actually about to run out of space, always ask it to summarize our conversation, give me the details that are important, that are factual, and give me an export of that, whether it's a Word document or give me it in Markdown or just give me the details. Then it will try to summarize all that information, then go over to a new chat. Doesn't matter if you're starting a new chat or in the same provider or a different provider, and then just say, hey, here is my previous conversation. I want to continue this conversation in a new chat, and it will try to, if it's summarized correctly, it will try to be able to bring over that conversation. Now, here's the problem that you may run into. Let's say, for example, you realize that it starts hallucinating. And in our example, our hallucination started on step 11. Let's pretend that you're already too late in step 11. You may not know in step 11 what you're missing. Because guess what? In step 11 here, we're actually missing some stuff because it compressed some of our data. So at this point in time, you only have two options. Option number one is you try to get the information here from the smaller state, or you go back through this conversation and then you grab everything you can, copy the screen, copy everything you can, and then open up a new chat and say, hey, this is my previous conversation. Please try and summarize it with all the facts and details for me and put that in a new conversation. So unfortunately, these are the limitations of using these things with I don't want to say small context sizes, but unfortunately, that's the problems we're dealing with now. Hopefully that answered the question, Shauna. All right.
Yeah, I'm sorry. I'm sorry, I had to unmute myself. It does answer the question. I was just wondering if there's like a hack. I'm sorry for I don't have a better word to say that, but just kind of like when you know that you've talked too much or you've asked too much, or because again, not everybody's detail oriented, and they may very well miss and be comfortable when they're actually missing quite a bit. Things are getting condensed, things are getting hacked. So anyway, if that's not possible, I can ask in the after hours, just not to take up more time. But you did answer for the most part what I was asking. So thank you.
Yeah, no problem. But there is really no hack. They're going to try to optimize and try to give the best user experience. And if you're not detail oriented, you're definitely going to miss those details that hallucinated. So always review your output of your large language model. All right. Does anybody else have any questions? Yeah, Johnny, do we have any questions in the live stream?
We do.
All right.
We got a cloud coder wants to know if local models are free. How do the companies make them the companies making them actually make money?
Yeah.
We talked about that already.
Yeah. So guys, just remember this. If you aren't actually if you're not actually paying for the product, you are the product, right? So if you're using a company like Google and you're using that Google to use your emails and you're not paying Google, guess what? Google's actually using your emails to do other things with it. So the thing is, there is going to be a catch at some point in time. So the biggest open source model right now is actually called Llama, and Llama is actually created by a company that you probably guys have known as Meta, and Meta makes Facebook. They're an ad-based company. So right now they're open source. They're actually doing everything as open as possible. And just like Linux is open source, just like how many things are open source, there is going to be a way that they're going to, in the future, find a way to make money. Usually the enterprise support licenses or whatever it is, they usually find some way. But keep in mind that they're going to right now just make it open source. They're going to make everything freely available to people and then figure out a way how to make money by either a enterprise license or something eventually. So that's how they actually will make their money. Great question. Johnny, any more questions? We have time for one more.
Yeah, there are more questions. So the numbers you showed us at the beginning of the show, they were huge.
Yep.
So nobody's doing that unless you're a big company. Nobody can afford that. But all the rage that I'm hearing online and on my doom scrolling about people that are using OpenClaw and NemoClaw and Claude Code, these are all people running local models of it, right?
No, they're not running local models. So this is what happened initially. So Claude allowed you to use your monthly subscription, which was unlimited, and got an API key. They were able to take that API key and plug it into OpenClaw or any of these agents. Once you actually plugged it in, it was using unlimited number of tokens, and Claude said, you know what, after about a month and a half, they said, we can't support this anymore. And they shut down using your API key from your all-you-can-eat monthly service because they only expect you to use your hands to actually type in the keyboard and not an agent to do it. So all of these competitors, they've changed their terms of service after OpenClaw came out about a month. So the people who got access to it for free, they lost all that value. The second thing is now they're using cheaper models, the Chinese models, and because the Chinese models are much cheaper, the costs itself are fractions of the cost. Now, those Chinese models itself may not be as good as the actual American models with respect to what they're capable of doing. But yes, people are actually migrating over to the actual Chinese models, which are fractions of the cost of the American models. Great question, yeah, Johnny.
Well, but at least you'll be able to get your feet wet and you'll have experience using models. And then maybe if you make enough money, you can switch over to the American brands. What do you say we move to the news?
Of course, let's get to the news. Yeah, Johnny, love it.
4.6 is expensive but brilliant. Anthropic just launched Open 4.6, securing its spot as the most intelligent model for agents and coding. However, it commands a massive premium of $5 per million input and 25 per million output tokens. That's what our show is about. OpenAI releases ChatGPT 4. Well, I guess it's just GPT-4. OpenAI has dropped it, their most capable model for professional work. They're heavily utilizing prompt caching, bringing cached inputs down to just a quarter per million tokens. Through output, though output still remains steep at $15. So it's both cheap and expensive. And Google Gemini 3.1 Pro preview. Google has officially rolled out Gemini 3.1 Pro preview, dominating the multimedia and vibe coding space. It is aggressively priced at $2 in and $12 out. Such a deal, making it the most cost-effective of the frontier models right now. So I am immediately going to my computer after this stream to audit every single API key that I have active right now. Seeing that simulator hitting 17,000 and plus made my stomach drop. So we've talked a lot about the magic of local models, but we haven't shown how to actually install one. That changes very soon. Next month in season 11, we are ripping the Band-Aid off. We're going to download, install, and run our very open models locally on our own machines. It's going to be wild. Junior, take us out.
Yep, and thank you guys for joining us today. Remember, this is our season finale for OpenClaw Bootcamp. It's 5 episodes of excitement, and we have our technical shows on Mondays, and as we get closer and closer to the end of the week, we actually get into the lighter philosophical debates of AI. Again, remember, all these classes are free, completely free, live. Just always sign up at airheadinstitute.ai, RSVP for all the classes so you can actually get reminders and share it with your friends. And do support us by becoming an Airhead Pro member, where you can actually join our Wednesdays office hours, where you bring all your AI questions. If you want to do AI after school for your kids, do that as well, Wednesdays at 3 to 5 p.m. Eastern time. And catch you guys in the next one. Later, yeah, Johnny. Later, guys.
Good to see you, Brad.
Thanks, guys.
That wraps up today's AI Power Up. If you joined late or you're new here, welcome to Airhead Institute. This is your daily destination for mastering artificial intelligence. We designed this lineup for everyone, whether you're a technical pro looking to upskill or you just want to chill and learn something new on your lunch break, we've got you covered. Our classes evolve every single month, so you're always on the cutting edge. And the best part? It's totally free to join. Once you're in, you can get live tips on your AI projects in our AI office hours and even enroll your kids in our Airhead After School program. Scan the QR code to join the community right now and make sure to like and subscribe at Airhead Institute on all socials. Guided by your hosts AI Junior and AI Johnny, we're here to help you win. Remember, AI won't take your job, but someone who knows how to use AI will. Don't get left behind. We'll see you next class. Bring a friend.